Hi, I'm Mr. Moran, and I'm a fourth grade teacher here at A.V. Cato Elementary. And I'm about to demonstrate and explain how and why our method of two-digit by two-digit multiplication is useful, is simple for your child, and just kind of take you through it so you can see what we do and why it makes sense for them and how it'll make sense for you. So here's an example of a question: 58 times 4. These arrows, these blue arrows, these numbers are hints for you right now. They're the steps, the order of the steps for the multiplication. So the first thing we're realizing here and we're noticing is that our 58, we kind of are showing the students, we've already shown them expanded form, expanded notation. And what this really entails is that it's 50 plus 8 that you're multiplying times 4. And so keep that in mind, because our first step, you'll see we teach the children, is to write what we call the baby zero. That zero is a simple reminder later when they bring that number down as a factor that that 5 in the tens place is not really a 5, it's a 50. So our first step, as you see here, it originates here with the 4. 4 times 8. So what they'll do is they'll write here 4 times 8. And then their second step is going to be 4 times 50. 4 times 50. And the 50, as I explained, comes from that 5 in the tens place. So now it's a matter of multiplying these simple facts here that they can do and making sure you line them up properly for when it's time to add them. So 4 times 8, 32. And 4 times 50, what we've taught our students is to kind of cover or ignore the 0 for now. And 4 times 5 is 20. And then that originating 0 in the ones place for the 50 comes back as the 0 here in the ones place. And now it's just simple addition, 232 is our answer. So let's take a look at another one. 75 times 6. Okay, so there's our first step, that baby 0, 75 times 6. Okay, and so our first pair of factors, we like to start off always the bottom. You're going to see why in just a moment. It creates a pattern that helps us check and make sure we're using the correct factors. So 6, I'm sorry, I did that wrong. That should be 6 times 5 and 6 times 70. I was getting ahead of myself with those zeros. And we put it over there and then we'll add them over here. It's kind of, it looks strange to us, but this way our addition work is all underneath the multiplication problem. So 6 times 5 is 30. And 6 times 70, once again, the 0, we kind of ignore it for a second, we cover it up. 6 times 7 is 42, and we covered 1 0, so we bring back that 1 0. We add them up, we get a 0, a 5, and a 4. 75 times 6 is 450. Now, two-digit by two-digit multiplication is just an extension of that. Again, the 36 times 24, what we're really looking at is 30 and 6 and 20 plus 4. Those are our two factors, just breaking it up in expanded notation. So now it's 4 steps. I know it's a lot of lines, a lot of color, but it's just what we were doing before. We were starting in the ones place with the 4. We're going up to the 6, and then from the 4 up to the 3. And now we'll have 2 more steps where we go from this 2 up to the 6, and from the 2 up to the 3. But again, we have to start with those baby zeros, reminding ourselves that those baby zeros are there to serve as reminders that these are, in fact, 30 and 20. So now we'll have 4 pairs of factors. 4 times 6 is our first step. And we like to start with that 4 down here, not 6 times 4, but 4 times 6. Again, you'll see the pattern here in just a second. Our other factors are 4 times 30. Our second pair of factors is going to be 20. We've got that baby 0. 20 times 6 and 20 times 30. So 2 things here. 1, we have our patterns. We have our 4 and our 4, a 20 and a 20. And then our 6 and 6, see it'll alternate 6 and 30 and 6 and 30. That the students should see that pattern anytime they do two-digit by two-digit multiplication. if they're doing it right, because otherwise they'll get mixed up and they might accidentally multiply 6 times 30 or 4 times 20. So we want to make sure and start at the bottom so we have the right sets of factors. The other thing to keep in mind here is that their largest product will always be the last one, because that's where they're multiplying their tens digit by their tens digit. So now, again, it's important to line up our products. 6 times 4, or 4 times 6 is 24. 4 times 30, we cover the 0. 4 times 3 is 12, and we bring back that 0 in the ones place. 20 times 6, we cover the 0. 2 times 6 is 12. Bring back the 0 in the ones place. And 20 times 30, we have 2 zeros that we'll bring back. 2 times 3 is 6, and the 2 zeros. And now we add it up, and it's 4, and a 6, and 8, 864. And for those students who like to add horizontally, what we like to tell them is take the first two and just add them. They should be able to do the first two in their head. 24 plus 120 is 144. 120 plus 600 is 720. So now they're just adding these two add-ins. They're going to add the 100 plus the 700, and that gives them 800. They're going to add the 40 plus the 20, and that's going to give them 60. And they're going to add the 4 plus the 0, and that gives them 4. And when they add that all up, 800 plus 60 plus 4, they know they have 864. So let's do one more. 68 times 79. We got some larger factors here. Again, we start with our baby zeros to remind us that those are tens. Excuse me, 9 times 8, always starting down here at the bottom, and 9 times 60. And remember the pattern. On this side, I should alternate. On this side, I should have the same factor. 70 times 8 and 70 times 60. And that'll be my largest product. So 9 times 8, 72. 9 times 60. 9 times 6 is 54. Bring back the 0. 70 times 8. 7 times 8 is 56, and I bring back my 0. 70 times 60, I have 2 zeros. 7 times 6 is 42, and my 2 zeros. I'll add it all up. 2. I can make a 10 here with my 6 and my 4 makes 10, plus 7 is 17. I can make another 10 here. 5 and 5 is 10, plus 2 is 12, and 1 is 13. And I've got a 5. Or again, if I want to add it horizontally, I can simply take 540 plus 72, and that makes 612. And 4,200 plus 560 makes 4,760. So now I'll just add 0 plus 4,000 equals 4,000. 600 plus 700 equals 1,300. 10 plus 60 equals 70. And 2 plus 0 equals 2. I'll add it all up. I've got my 2, I've got a 7, I've got a 3, and I've got a 5. 5,372. Now, one thing we like to show the students on this is about checking their work using reasonable numbers, using reasonable estimates. So 36 times 24, once I'm done with my work, I can obviously check my multiple choice answers if I was taking a test to see that I've got one that matches. But if I might be doing what we call the griddable answers, which are situations where the students have to bubble in whatever answer they got, and there is no multiple choice. There's nothing guiding them to whether they got the correct number. They have to write it in these boxes and bubble it in the spaces below. So the way I could check to see did I get a reasonable answer here is to do simple multiplication in my head. I know 36 I could round to approximately 40, and I know 24 I could round to approximately 20. And the student should be able to do 40 times 20 in their head and get 800. Doesn't mean the right answer is 800, but my answer should be somewhere in the vicinity, somewhere in the neighborhood of 1800. And as when we did it before, 36 times 24, my answer ended up being 864. So I know I have a reasonable answer. If I had gotten a different answer entirely, if my work had yielded a result that was 8,640 because I moved my numbers over somehow or made a mistake somewhere, then I know I could go back and check that my reasonable answer of 800, that's my guide, that's how I check my work, then 8,640, I'm way off. I've got to go back and do something again. I've got to go check something. So reasonable answers are the way for the student to check their work, and the 2 by 2 digit is just breaking down the numbers into smaller factors to where all the student really has to know is 9 times 9, anything smaller. I hope this has been helpful. If you have any questions, please don't hesitate to ask your teacher.